So we continue with the chapter radioactivity and we start with the part of radioactivity. Henry Becquerel discovered the phenomena of radioactivity in 1896. So it was in the year 1896 that Henry Becquerel discovered the phenomena of radioactivity. How did it happen? Let's see. Once in a dark room, he left a uranium salt placed on a photographic plate wrapped in a black paper. After some days, he was surprised to find that the photographic plate had been affected. Later on, the same observation was made with the other salts of uranium. From this observation, he concluded that uranium, its salts by themselves, emit some kind of radiation which can pass through covered or black paper or glass or wood etc. of the photographic plate and affect it. These radiations were called as Becquerel rays. Okay, so what it says that Henry Becquerel was accidentally in a one dark room. He had got some photographic plates. The photographic plates were always covered in a black paper and all, so normally they would not have any effect by the light. So there is no way the light could have entered inside. But still, when one particular uranium salt was kept near it, it was found that the photographic film was affected and the photographic film got white. So because it was affected, he could judge that when he tried once again with another kind of a uranium salt, he found that the same kind of condition happened. So it was concluded that uranium gave out some kind of rays which were affecting the photograph, or which can pass through the black paper, or it could pass through wood and all, and which are going to affect the photographic film. So this were the radiations which were understood, and they were given the name as Becquerel's rays. Becquerel rays. Becquerel rays. On further investigation, these radiations were found to be of three types: positively charged, negatively charged, and uncharged, which were then named as alpha, beta, and gamma radiation. So it was this way. There were the three radiations. One was the alpha, that is alpha. This were the positively charged rays. The beta, that is beta. These were the negatively charged rays, and the gamma, which were this is gamma, which has no charge. So this is no charge. Okay, so this way you have got the alpha, beta, and gamma. So alpha, the positively charged particles; beta, the negatively charged rays; and the positively charged rays, alpha, beta, the negatively charged rays, and uncharged as gamma radiations respectively. The substances which emit these radiations were called as radioactive substances. Thus, the substance which disintegrate or decay by the spontaneous emission of radiations are called the radioactive substances. For example, uranium, radium, polonium, thorium, and actinium, etc. So let's give us the radioactive material definition as substances which disintegrate or decay. The substances which disintegrate or decay by the spontaneous emission of radiations are called as radioactive substances. The isotopes of nearly all the elements of the atomic number higher than 82, that is after lead in the periodic table, are radioactive because in their nucleus the number of neutrons is much more than the number of protons. These are called the natural radioactive substances. So in the periodic table, when we see the periodic table, any number which is about 82, so atomic number 82 के ऊपर के जितने भी elements हैं, these elements when they are going to be they are called as natural radioactive substances because they have a vast difference between the number of protons and the number of neutrons present in the nucleus of the atom. So because in the difference in the number of protons and the number of neutrons, they are unstable atoms. The nucleus is unstable, and that causes the radioactive the phenomena. So radioactivity is a nuclear phenomena. So let's understand what is radioactivity. It is a nuclear phenomena. There is no connection of the electrons in the particular of the atom. So it is completely based on the nucleus. Any physical change such as change in pressure and temperature or chemical change such as excessive heating, freezing, action of strong electric and magnetic field, chemical treatment, oxidation, etc. does not change the nature of radiation emitted by the substance and its rate of decay. So that's the most important part. You are unable to control the radiations because any change in the pressure or temperature or any chemical change of heating or freezing or a strong electric or magnetic field, ये कोई भी चीज, okay, none of these are affecting the radiations what are going to be given out by the nucleus. So that's why it is unaffected by any kind of physical changes like pressure and temperature nor any kind of chemical changes. This clearly shows that the phenomena of radioactivity cannot be due to the orbital electrons which could easily be affected by such changes. The radioactivity should therefore be a property of the nucleus. See, normally if you apply some heat, automatically there is a loss of electrons, emission of the heat, emission of the electrons. So वो सब कुछ होता ही है. अगर प्रेशर अप्लाई किया तो भी डिफरेंस आ जाता है. You do some chemical changes, तो chemical change में भी तुरंत ही इलेक्ट्रॉन्स का मूवमेंट आता है. Whereas if this particular thing has no effect on the change of physical and chemical changes, in such a case we can understand that this particular change has to be a nuclear change. So it is a change which takes place in the nucleus. Thus we define radioactivity as radioactivity is a nuclear phenomena. Okay, radioactivity is a nuclear phenomena. It is the process of spontaneous emission. It is the process of spontaneous emission of alpha, beta and gamma radiations from the nucleus of the atom during their decay. Okay, that is radioactivity. What is radioactivity? Radioactivity is a nuclear phenomena. It is a nuclear phenomena. It is the process of spontaneous emission of alpha, beta and gamma radiations from the nucleus of the atom during the decay. Note, from the radioactive substance containing a very large number of atoms, there is no way to know or predict when or which nucleus of the atom will decay at any moment. Hence, the radioactive decay is a random phenomena. Okay, you cannot identify कि हाँ देखो अभी ये condition है ना, अभी ये radioactive होगा, अभी ये condition है तो ये. There is no such thing like a condition which is going to set that particular thing that okay हाँ ये condition आएगा तो ही radioactive होगा. It's nothing like that. So you can see that the radioactive is a nuclear phenomena, and moreover it is a random phenomena. It is just like suddenly it is going to take place. It is not that it is going to take place only under certain conditions or certain kind of a place. It is a random phenomena. So we see that radioactivity substance contain a very large number of atoms. There is no change, no way to know or predict when or which nucleus of the atom will decay at any moment. Hence, the radioactivity decay is a nuclear phenomena. That is, random phenomena. That is, there is no law by which the disintegration of an individual nucleus can be known or predicted. So there is no law which can predict the radiation could take place. Now let's see the radioactivity as emission of alpha, beta and gamma radiation. So now we come to the main part of the chapter, that is the understanding of what is alpha, beta and gamma radiations, what are they made up of, what is the properties of them, how we can calculate the condition after the alpha particle is given out or beta particle is given out by an atom. So all these things we are going to study now over here. So radioactivity as emission of alpha, beta and gamma radiations. In 1903, Rutherford experimentally studied the nature of radiations emitted by radioactive substances. He found that on subjecting the radiations given out by the radioactive substance to a magnetic field, in a particular direction perpendicular to that path, they separate out into three distinct constituents as shown in figure 12.4. So Rutherford, when he was studying the radioactive substances, and when he placed the radioactive substance in between, and then he placed it in a magnetic field. So when he placed a magnetic field, he found that the particles were getting deflected. Okay, the particles were getting deflected in a particular manner inside the which are coming out from the radioactive material. So he found that on subjecting the radiation given out by radioactive substance to a magnetic field in a direction perpendicular to that path. So the magnetic field were made perpendicular to the path. So अगर ये path है तो perpendicular, ये path है तो यहाँ पे अगर perpendicular to the path में अगर magnetic field रखा तो there were deflections taking place. They were separated out into three distinct constituents as shown in figure, in which magnetic field is normal to the plane of the paper inwards. Thus, which turn to the left must be positively charged and are called as alpha particles. So remember this thing, whenever you are placing the thing in a magnetic field, the one which is to the left, okay, one to the left is alpha particle, one to the right is beta particle, and which is going straight is gamma. Okay. So those which turn to the left, now why do they turn left is because of the Fleming's. The direction of reflection in the magnetic field is given by the Fleming's left hand rule. This Fleming's left hand rule, which is there, we are going to study it in the chapter that is the electromagnetism part. So that we will study is the Fleming's left hand rule. So based on the Fleming's left hand rule, it is like this. You have to put your left hand like this. So this is the force, okay, this is the magnetic field, direction of the magnetic field, and this is the direction of the current. So we are saying the same thing, that over here they are perpendicular to each other. Accordingly, you will find that the positive charge is going to be attracted towards the left hand side. Right, so those which turn to the left must be positively charged and are called the alpha particles. Those which turn to the right must be negative charge and are called as the beta particles. The beta particles are deviated more than the alpha particles. Those which pass undeviated must be uncharged or neutral and are called as gamma radiations. Gamma radiations are electromagnetic waves. So that's what we see over here. So what they said is, if you have got a magnetic field, so this is a container containing the radioactive material inside. So this material inside is radioactive, so it is going to give out radiations. So when it gives out radiations, if I place a magnetic field over here, so when I place magnetic field over here, it is found that to the left hand side over here will be going are the alpha particles. These are the alpha particles, and they will not be deviated much. They will be able to go a longer distance straight because they are not deviated much. Whereas the beta particles are immediately going to get deviated to the right hand side. So these are the beta particles, and the radiations which are undeviated are the gamma radiations. So this is what you've seen, that the alpha particles will be going to the left, the beta particles will go into the right and more deviated, and this is the gamma which is going to go straight. And the magnetic field is inwards, so because the direction of the magnetic field should be known, so it is inwards, so it is like this. Okay, so you are having it inwards. Okay, so gamma radiations are the electromagnetic waves similar to the light waves and are therefore not affected by the magnetic field. We know very well the light rays are not affected by the magnetic field. Accordingly, we can see that the gamma radiations, these are the gamma rays. The gamma radiations are unaffected by the magnetic field or electric field because they are electromagnetic waves similar to the light waves. Similarly, if the radiation given out by the radioactive substance are subject to an electric field in the direction perpendicular to the path, they again separate out into three constituents as shown in the figure 12.5. Those which turn towards the negative plate will be the alpha particle, the positive charge alpha particles. particles, those which turn towards the positive plate are the negative charge beta particles, and those which pass undeviated are the uncharged gamma radiations. The beta particles are deviated more than the alpha particles. The same thing, instead of the magnetic field, if I put the plates, then I know that this plate over here, it should be negatively charged because the alpha particles are getting attracted. So this is the negative charge and this is a positive charge. So because it is a positive charge, so the negatively charged particles are attracted towards it. So the beta particles get attracted towards the positive charge. The alpha particles are attracted towards the negative charged plate. So that is how they are going to be deflected, and here also the same way the beta particles are deflected much more than the alpha particles, whereas gamma goes straight. Now we see the properties of the alpha, beta and particle particles one by one. So let's see. First thing, properties of alpha particles. Some properties of alpha particles are given below. An alpha particle consists of 2 protons and 2 neutrons. It is same as a doubly ionized helium atom, that is a helium nucleus containing 2 protons and 2 neutrons. It is represented by 4 He2 or He2 plus, and B, figure A and B represents the model of the neutral helium atom and the helium nucleus of the alpha particle. If an alpha particle H2 plus gains 1 electron, it changes into a singly ionized helium atom, and if it gains 2 electrons, it changes to a helium atom. So we can see that the alpha particle is like this. It is just a simple nucleus having 2 protons and 2 neutrons. This is therefore we can consider it to be as a helium nucleus which is not having its electrons, that is He2 plus. Okay, and we can call it as He, and the mass will be 4 and the number of protons is 2. So mass number 4 and the atomic number will be 2 over here, as which is the case of helium, and it is called He2 plus. So this is the structure of the alpha particle. So alpha particle is made up of 2 protons and 2 neutrons. So it is a nucleus of helium. A helium nucleus is what an alpha particle represents. Alpha particle can be represented as a helium nucleus. The mass of an alpha particle is roughly 4 times the mass of proton, that is 6.68 into 10 to minus 27 kg, and its charge is twice the charge of the proton, that is 3.2 into 10 to minus 19 coulomb, that is 2 Thus its specific charge is 4.79 into 10 to 7 coulomb per kg. So that is the mass and the charge ratio. So mass of course is equal to 4 over here, so that is 4 protons, or we can say it as given as 6.68 into 10 to minus 27 kg, and its charge, of course, it has got 2 protons, so it is positive 2 into 1.6, that is 3.2 into 10 to minus 19 coulomb. So that's why the charge per upon mass, okay, charge upon mass ratio will be given as 4.79 into 10 to minus 10 to 7 coulomb per kg. The speed of alpha particle is of the order of 10 raised to 7 meter per second. It is different for alpha particles emitted from different radioactive substances. Further, all the alpha particles emitted by the nucleus of the same radioactive substance do not have the same energy or speed, but they have energy distributed in a small range. So this is something unique, that we cannot say that the alpha particles are going to move at a particular speed. Okay, its range, its approximate order will be 10 raised to 7 meter per second. So speed is 10 raised to 7 meter per second. But different atoms will have different speeds in which the alpha particles will be emitted. Not only that, same elements but different atoms, they have got also different speeds. So that's the main thing, that the speed will be all alpha particle emitted by nucleus of the same radioactive substance does not have the same speed. Fourth point, alpha particle strongly ionizes the gas through which it passes. The ionizing power of alpha particle is roughly 100 times that of beta particles and roughly 10,000 times that of gamma radiation. So yeah, you can see that alpha particles, they are having two positive charge. Because it has got two positive charge, that's what it is. It is quite a heavily charged body, and because of the charge present in it, that's why from wherever the alpha particles passes through, it can easily ionize the air through which it passes through. Okay, so if we compare the alpha particle properties with the beta and the gamma, it is found that the alpha particles are 100 times more ionizing power. Alpha particles has got 100 times more ionizing power than the beta particles and 10,000 times more more stronger ionization power than the gamma radiations. Fifth one, an alpha particle readily dissipates its heat as it moves through a medium, and therefore its penetrating power is quite less. It can penetrate only through 3 to 8 centimeters in air. It can easily be stopped by a thin card sheet or thick paper. Its penetrating power is roughly 1 upon 100 times that of beta particles and 1 upon 10,000 times that of gamma radiations. See, alpha particle is a big particle. It's a big particle because it is almost one nucleus of the helium atom. So that's why it is quite heavy and big. Because it is heavy and big, so when it is traveling, at that time it loses its energy. And because it loses its energy while traveling, that's why its penetrating power decreases. Okay, hence alpha particles has got a very less amount of penetration power, so much that it can easily be stopped by a thin cardboard kind of a thing. It could be, it can penetrate only 3 to 8 centimeters in air, and it can be easily be stopped by a thin card sheet or a thick paper also. So the penetrating power is 100 times less than that of the beta particles and 10,000 times less than the gamma radiations. We move on to the sixth part, that is alpha particles are positively charged, so they are deflected by the electric and magnetic field. The deflection after particles is less than compared to the beta particles because alpha particles is a more mass than the beta particles. So yes, alpha particles are positively charged, and because of being a positively charged, they are deflected. We can see that they are deflected by the magnetic field or the electric field. So electric field and magnetic field, they do deflect the alpha particles, and not only they deflect it, but they also see that alpha particles are less deflected as compared to beta particles because of its mass. So the deflection of alpha particle is less than compared to the beta particles and much more because alpha particle is more mass than the beta particle. Alpha particles affect a photographic plate. Yeah, that is already known. Alpha particle affects the photographic plate. Alpha particle causes fluorescence on striking a fluorescent material. Yes, they have got fluorescence, so they are going to create fluorescence, that is brightness or shining in the dark part. So whenever fluorescent material like sulfide is used, so it is going to be zinc sulfide, वहाँ पे glow होगा, that is nothing but fluorescence. Alpha particles have large kinetic energy and momentum with them. They are used to bombard the nucleus of the atom of one element to convert it into another element for transmutation. So alpha particles, as I told you, this is a big mass. It's a huge mass because 2 protons and 2 neutrons है, इसलिए 4 mass का है वो. That's why they are going to be because they are heavy, they are used for bombarding them on another metals so that they can decay or they can be split into smaller elements. That is called as transmutation. Alpha particles destroy the living cells and are also cause biological damage. Yeah, they can destroy the living cells. Of course, they do not have that much penetration power, but still they can destroy when they enter into the body. And they get affected. Come in contact with the body, then definitely they are going to kill the cells. So destroy the living cells. Alpha particles get scattered while passing through the thin mica or gold foil. So when the alpha particles are made to pass through a mica or a gold foil, they are deflected. So they are going to scatter, and while they are, and that particular thing was the principle what was used by Rutherford to find out the nucleus shape, so atomic structure. So that is the alpha particles what he used. This is the same alpha particles what we are having over here. So that was about the properties of the alpha particle. We continue with the properties of beta particle in the next video. Yeah. Okay, I think I can continue with the beta. No.